us an opening prayer? You can raise your hand and you participate in the opening prayer, and then we get started. Martha, Victor, any of you can give us an opening prayer. Even if you are a Muslim, no problem. You can start for us.
Esther, can't you pray for us? Esther? Unmute. Oh, Grace, should I assume that people don't know how to pray? Okay, I see Ben. Yes, Ben, can you pray for us? Unmute.
Yes.
Okay, let's have ourselves and pray. Father, in the name of Jesus, we want to thank you for today's platform seminar. As we are going to start, we pray that the Holy Spirit will guide us in each and everything that we are going to discuss for the good of our physics group and the students of Uganda at large. I thank you. In the name of the Father, the Son, and the Holy Spirit, we pray.
Amen.
Amen.
Amen. Thank you for that opening prayer. At this point, I'm going to invite our facilitator, our teacher, Mr. Alira Daniel, to take on the physics seminar. I will come back later for more communication. Teacher Daniel, you're most welcome.
Thank you so much, Mr. Bernard. Before you go, let me take this chance to thank you for organizing this and also for being behind this. I want to thank each and every member who has made it a point to join this seminar. I'm sure we are not going to live here without benefiting, but then by the time we go out of this place, at least something small will have changed in our hearts. I start by introducing myself. I'm called Mr. Daniel Alira. I'm a teacher of physics and mathematics. And I chose to be a teacher way back in 2007, actually 2008, when I was in senior 2. I was really impressed by my physics teachers. And not only that one, I was also impressed by physics itself. So I said, now what should I do? I chose to be a teacher. I said, what should I do now? If I'm to be a teacher, then what should I teach? I was impressed. I said, let me teach physics and mathematics. Actually, I wanted to teach 3 subjects. Unfortunately, when I reach at campus, they can't allow you to do 3 subjects because I wanted to teach physics, math, and chemistry at the same time. They were so sweet. And why I chose physics? Because it had been a challenge to very many of my colleagues. And yet, the content looks to be very simple. But as I talk now, for the few years I've taught, I've got to know why it's that way. And I'm here to tell you that the subject which we call physics, if I'm not mistaken, is one of the simplest subjects which we have in O level. That's me as a person, and everybody whom I interact with, after discussing physics with, he also tells me that it seems this subject is also very simple. So I want to appeal to my dear learners that physics is one of the simplest subjects which we have in O level, and even in A level, by the way. You just need to have the positive attitude you have to be open-minded and allow physics to work in you. The group here we are called YAKA. This is YAKA Digital Network. It's an organization which is based in Makerere, and it's a school on its own. So we said, why can't we have a seminar so that we can unite our students and also the rest of other students from all parts of the world. We are going live right now. Those who are not able to attend from here, they are going to be attending they will attend from YouTube because we are going live. So we are not only in Uganda, but we are everywhere in the world. My friend, Mr. Bernard, will talk more about YAKA Digital Network, but basically me, I'm talking about physics. So today's seminar is going to take about 2 hours roughly. And so that means you're going to dig deep into something that is going to help us at the end of it all. In case you have any submission, any query, please feel free to raise up the hand and submit. Feel free to raise up the hand and ask the questions which you feel like you want to understand. And the most important thing here is that we need to understand the physics so that we don't just cram the words which the teachers give us in the notes. You see, why people find it so challenging is because we want to produce exactly what the teacher is giving in the notes. That is not possible. We are not computers that we can cram those things. But if I say mode of operation of a transformer, then I need to know the principles on which the transformer works. In that, even in my own words, I can speak how a transformer is able to conduct or to transmit, to step up or step down the voltages, even without the notes from the teacher. So my fellow learners, I mean my learners, and also the fellow teachers who are here, let's have these learners master not the words, but understand what is behind the physics. The moment you understand that, then the rest will be very simple. Today we are going to see what we mean by understanding basically the concept, and then we move on. Those who have not received the questions, I'm going to share it in the chat here. I'm going to share it in the chat here. So you will download it. Then after downloading, you will be in position to read the questions and also pound on it during your free time. The discussion is going to be learner-centered. However, it's going to be headed by me. And as I've told you, in case you have a problem, I mean, you want to find out something, please feel free to ask questions or raise up the hand, or you use the chat room. I'm sure I have 80% candidates here. Seminar questions are already in the chat room. Please check the chat room. I'm sure we have about 80% candidates here who are yet to sit for the exams come October. I'm praying for you so that at least you make it a point. Please feel free always consult us. We are always available online 24 hours in case you don't get in case you get any challenging question, you can just tap on us and you find the solution to the problem. If there is no query, allow me go direct to the seminar, unless there's anybody want to inquire. If you want to inquire something little, before we start off, then it's very fine. About the seminar, we are going to do it. Okay. Allow me share my screen with you so that we can kickstart this. I believe we can see the screen. Please let me know so that we can move on.
Yes, we can see it very well.
Okay, thank you so much. We're going to start with the light question. Light is one of the questions which one of the topics which has always been there in our UCE. But as we do this, we should not do it with the aim of passing only exams. But if you read physics with the aim of understanding, trust you me, you will love physics for real. Not with the purpose of writing the exams and passing them, but with the purpose of understanding physics. You will understand physics. I'm sure you're going to enjoy physics. You will love physics. I don't know. You will just, you even dream physics because it is as sweet as, I don't know what I can call it. So we are starting with a simple part of light, just an introduction. We say that light is just a form of energy which enables us to see, but light is in dual. We said dual, light is dual, that is D-U-A-L. When you say dual, that means that it behaves in two ways. Light behaves as if it is a wave, and at the same time, it behaves as if it is a particle. So light itself, scientists have failed to place light. Sometimes they want to call light to be wave, and because it has some properties of the waves, sometimes it is a particle. There is one of the animals in biology which is called Mr. Bat. Mr. Bat is an animal, partly an animal, partly a bird. So people always confuse it. It's an animal, it's a bird, it's an animal, it's a bird. Why? Because it possesses the characteristics of a bird. It also possesses the characteristics of a what? Of an animal. That is a mammal. Light is also like that. It possesses the characteristics of waves and also possesses the characteristics of a what? Of a particle. Light as a wave, we see ahead one of the properties of light, which is not very common in our O-level physics, but it is that light can be polarized. That is polarization. Because it can be polarized, it can undergo refraction, it can undergo reflection, it can undergo interference, and also diffraction. We say light is a wave. But when you go deep in modern physics, under photoelectric emission, senior fours will tell us that photoelectric emission, who can define for us photoelectric emission? Photoelectric emission, you can raise up the hand. Yeah, photoelectric emission. Hello. Photoelectric emission, you can raise up the hand. MG, I don't know who is MG. MG says, Maria Candy Tinker. You can unmute Maria Candy Tinker.
Photoelectric emission is the process through which certain metal surfaces emit electrons through electromagnetic radiation of sufficient frequency.
Very good, very good, very good. The process by which a metal emits radiation, emits electrons, when an electromagnetic radiations of high enough frequency falls on it. That's what we call to be photoelectric emission. Photoelectric emission is the process by which a metal surface emits radiation when high enough frequency, when an electromagnetic radiation of high enough frequency falls on that metal surface. It is found out that light, when incident on a metal surface, it also causes photoelectric emission. That means that light possesses energy, and energy is only possessed by a particle. We don't have free space cannot possess energy. Energy is possessed by a particle. So light possesses energy which gives to the electrons of the metal surface, and these electrons are then ejected from the metal surface. Because light causes photoelectric emission, then it is considered to be a particle. Somebody named MG asked a question, of which I guess I've already answered it, that what are those properties of a wave that makes it behave? What are those properties of light which makes it behave as if it's a wave? We said it can be reflected, that is light. 2, refracted. 3, diffracted. 4, it can undergo interference. 5, it can undergo polarization. So briefly, that is the background of what we call to be light. Dear friends, if we want physics to be as sweet as possible, don't read physics with the purpose of passing exams. Read physics with the purpose of understanding it. When you read it with the purpose of understanding, trust me, you will be seeing in physics, you will be dreaming physics. Even when you're eating, you just feel like, sometimes when I'm talking about physics, I feel like, for sure, I even don't know where to stop, but I just speak it. Where the time gets me is where I will stop. So if you could do that, sir, can you repeat? That is, sir, could you please repeat the definition of photoelectric emission? That is Kusima Peter. I said photoelectric emission is the process by which an electron, photoelectric emission is the process by which an electron is ejected from the metal surface. Process by which an electron is ejected from the metal surface when electromagnetic radiations, when an electromagnetic radiation of high enough frequency falls on it. Is the process by which an electron or electrons are ejected from the metal surface when electromagnetic radiation of high enough frequency falls on it. Good. So that's that. Now, we're going to see one of the properties of light. And basically here, we are talking about reflection. And reflection, we are going to narrow down to pinhole camera. So question number 1 says, with reference to pinhole camera, explain the effect of the following with reference to the pinhole camera. Explain the effect of the following. So before we see the effect of those, a pinhole camera hope you can see on my screen what I'm trying to write on my board. Are you able to see what I'm writing on the board? You can
Yes.
just give me a signal.
Yes.
Okay, good. So a pinhole camera is made from a box. It is just a box with a hole. So this hole is what gives it a name. The hole is very small. That's why it's called to be pinhole. It's a box with a hole, and the inside is blackened. This is our pinhole camera. So when an object is placed in front of a pinhole camera, let's say this is our object, is placed in front of a pinhole camera. The ray from the object will come from there, and it will pass through this. It will pass through this hole. And this will go there, then it will pass the other side. So finally, the image is going to be formed behind the mirror. This is the leg. This is the leg, and this is the head of the image. So when you see the image is there, it will be formed here. So this is the head. The head is down, and the top, the legs will be the other side. So this becomes our object, and this becomes our image. The distance from here to here is called to be the object distance u, and the distance from here to here is called to be the image distance v. If I may ask, what are the properties of the images formed by the pinhole camera? Properties of the images formed by pinhole camera is in Goma. Emma?
Yes.
You can unmute Emma.
Sure.
I don't know whether it's
Yes,
me who is not hearing, Emma.
images,
Very good. The images are upside down. We say inverted. Very good. Victor?
The image is
Victor
diminished.
Mesigwa?
The image is diminished.
Diminished. The images are diminished. We are going to see the diminished part because it depends on some few factors. Maria? Yes, Maria. Maria,
image-
great. Maria, great.
The image is colorful.
Somebody is saying that the image is colorful. Yeah, that's physics. Physics is sweet. but it's not colorful. Yes, Maria, Tinker, Candy.
The image is magnified.
Magnified. Okay, good. Let's check in the chat. Joshua says the image is colorful. Eriki says they are virtual. Yes, but the images formed here is not virtual. Martha says the image is colorful. I like this. Jonathan says the images are not so bright. Good. I like the answer given by Kusima Peter. The image is inverted. Okay. So one of the properties of the images formed by the plane, by the pinhole is here. First of all, if you look at this object, the object is upright and the image is inverted. So the image is what? Is inverted. You can as well use upside what? Upside down. That is one. Two, when looked at this ray and the other ray, they are meeting, leading to the formation of the image. So when we have action, there's a word we call to be action and virtue. Actual or apparent. You can call it apparent or virtue. When two rays meet, and then the type of image and when we have apparent intersection of light rays, then the type of image formed. So we have here virtual images, and here we have real what? Real images. So real images are those which are formed by actual intersection of light rays. And virtual images are those which are formed by apparent intersection of light what? Of light rays. Fortunately or unfortunately, these two rays are actually meeting here. They are meeting. We see them meet. So here we say there's actual intersection of light what? Light rays. And so which type of image is formed here? It is what we call to be real image. So the image is real. Now, I want to talk about magnification. I want us to talk about magnification. Some people are saying that is magnified, others are saying that is virtual. True, it always confuses people whether the image form is magnified or virtual. I'm not surprised to see ourselves confused here and there. But now you have to bear in mind that when you are going to say that the image is magnified, then that means that the object size is less than the image size. Magnification, if we may say magnification, is given by the image distance divided by the object distance. I hope we are well acquainted with this. Now, when do we say that it's magnified? It is magnified if V is greater than U. It is diminished when, and lastly, we say that the image E equals to what? U. Here, there is magnification, magnified. Here, we say diminished. And here, we say that object size is equal to the image what? Image size. Is that okay? Now, Okay. Maria Great says, teacher, can you pardon on the explanation of actual and apparent? I can't wait to do that. I've already talked about actual and apparent. When you're talking about actual intersection, I think I have to use the example where we're going to use the example where we have the apparent and then the actual intersection. If you consider a ray, let's say like that, and then I shade it from here. Yeah, this is convex. Somebody's saying it. And then I draw my principal axis. Then this is my object. Then this ray will come and it will strike it at this point. Then it will divert like that. So this ray which has gone here, it appears to be coming from somewhere here. Are you seeing it? So if I draw another ray from here to meet this one, they are meeting at this point. This ray is not there. This one you're seeing is not there. It just appears to be coming from there. It appears to be coming from there, but it's not there. So that's what we call to be apparent. And what we call to be here, like the way this one you see, is not appearing to be coming from here, but they are meeting at that point. That is what we call to be the actual. So the actual intersection of light rays is what leads to the formation of the real image. And the apparent intersection of the light rays is what leads to the formation of the virtual image. Hope that is clear now. Please let me know whether it's clear. Is it clear now on the apparent and the virtual? Okay, good. Let's move on. We are moving on to teacher. What is the difference between the real and the virtual? I was still explaining. When you say virtual, they say it is produced by and real is produced by the actual intersection of light rays. Okay, good. Let's move on. We move on to this question of ours. So the question our issue is, I was explaining about magnified and diminished. So when we say that it's magnified, that means that the image distance is greater than the object distance. That will be magnified. And if the image distance is less than the object distance, that will be diminished. And if the image distance is equal to the object distance, that means that the object size is equal to the image size. Good. What about a plane mirror? I mean, what about pinhole? Pinhole has fixed image distance. The distance from here to here is the distance of the pinhole. The distance from here to here is the distance of the length of the pinhole. And so it becomes the image distance. It is fixed. It is fixed. This is our V. It does not change for a pinhole. Now, from our magnification equal to V out of U, as we have just seen. Now, I want to ask somebody, if this one is not changing, if V is not changing, and I'm increasing the image, this object distance, teacher, what examples of objects form virtual images? All objects are able to form either real image or virtual image, depending on the type of the mirror in which it's placed. Say of a concave mirror. For a concave mirror, it has a possible images. But all objects, Grace says, which direction is the virtual image? The direction of the virtual image depends on the position of the object. That is detailed physics now, but depends on the position of the object. But can either be formed behind the mirror. If it's a mirror, it is formed behind the mirror. But if it's lenses, it's formed in front of the lens. But if it's a mirror, it is formed behind the mirror. Good. Let's move on. Now, I was asking about this. If the image distance is fixed, if the image distance is fixed, and I increase the object distance, I think you can see. That means that I'm pulling the object, I'm putting it here, somewhere here. What will be the effect on the magnification? Just from this formula, you will be in position to tell who can give us the effect of increasing the object distance. You can raise up the hand. What is the effect of increasing the object distance on the magnification in a pinhole camera? Yes, please. Hello? Can I see hands up? Okay, I see Lauren. Yes, Lauren.
Yes, that will be diminished.
Very good, very good, very good. I like the way of seeing it. When you increase U, that means that the whole expression V over U will be very small. It's like putting 5 over 3 and you put 5 out of 2. Here U is big and here U is small. So where there is small U, the magnification is big. This is 2.5. What is 5 divided by 3? Somebody with a calculator? What is 5 divided by 3? Is there somebody with a calculator? Yes, Raza? Raza?
1 remainder 2.
1 remainder 2. That is 1 point what? 1.66. Martha says 1.66. Yeah. So here is 1.66. So you can see that if the object distance is big, the magnification is small. And if the object distance is small, the magnification is big. Now, we come and say, when you move the object away from the pinhole, the magnification reduces. Is that statement correct? Can somebody confirm that by saying yes or no? When you move the object away from the pinhole, the magnification reduces, or the image is diminished. Can somebody confirm yes or no?
Yes.
Maria Rosa says yes. I want another yes.
Yes.
Yes, good. That means we have picked that. What about if you move the object towards the pinhole? Who can give us the answer then? Towards the pinhole, what will happen to the magnification?
It increases.
Very good. The magnification increases. That is from Maria Candy Tinker. Maria Rosas also says it will increase. I like these people called Maria. I think that's why even Jesus Christ was born by a lady called Maria. Jesus Christ also like them. Okay. When I grow old, when I become young, I'm going to start my name Maria. Maria, great. Okay. So that is that when it comes to the pinhole. Now, our question was, with reference to the pinhole, explain the effect of the following. Increasing the object distance from the pinhole. Do we have the answer now? Do you have the answer now?
Yes, we do.
We do. Remember, I was just explaining. I didn't know that there was even a question anyway. You're talking about that. But eventually, we have answered the question. Emma? Is Ngoma Emma?
Yes, teacher.
Yes, please. Tell us. Good. Bringing the object closer to the pinhole. Who can tell us what will happen when you bring the object closer towards the pinhole? When you bring the object closer towards the pinhole, you can raise up the hand. Yes, Emma?
The magnification will increase.
Very good. This is what I want you people to do when it comes to physics. Don't read physics with the purpose of answering the question, but read physics with the purpose of understanding. And when you read it with the purpose of understanding, then automatically you will have what? You will have answered the question. The magnification increases and it will become blood. You should not forget that. You should add the word blood. It will become bigger and blood. Why blood? Because if it becomes very big, the same amount of light which you would have used, which you would have been used on a smaller image is now used on this bigger image. So you find that the light is not big enough, which can cover up all the what, which can shine on all parts of the image, because the image this time around will be bigger. Good. I like this class. I wish I meet this class every day. We would be speaking only physics for sure, Mazima. Physics. Teacher, another word for diminished. Another word for diminished is that the object is smaller than the image. I mean, yes, the object is smaller than the image. The object is smaller than the image. That's what I can use possibly. Okay, Maria Great says, okay, thank you. Thank you so much, Maria Great. Let's move on. Part 2, Part Fury says, Part B, I mean, an object of height 4 centimeters is placed 5 centimeters away from the pinhole camera. The screen is 7 centimeters from the pinhole. Draw a ray diagram to show the formation of an image by the pinhole. What is the nature of the image? Find the magnification and explain what happens to the image if the pinhole is made larger. Okay. Mr. Bernard? Hello, Mr. Bernard?
Yes.
I was requesting that you take over for 2 minutes as I come.
Okay, fine.
Okay, please.
Okay. Yes, all of us who are here, I still welcome you to today's seminar. As Teacher Daniel introduced the Yaka Digital Network, with the Yaka Digital Network, we are giving you these free seminars. We have as well set up different mock papers. These mock papers are also free of charge. When you create an account on yaka.cc, you can access these papers free of charge. I've sent the registration link in the chat section, yaka.cc/register. So when you create an account there, you will be able to see these mock papers and you attempt them. The teachers will mark them and return your scores. Yours is to ensure that you have an account on Yaka. We also have free reading materials like your subjects. If you are maybe in senior 2, senior 3, senior 4, senior 5, senior 6, or even in primary, you can visit Educare. It has free reading materials. If you also create an account on Educare, you are able to read those subjects free of charge. So if I can show you Yaka and then Educare. So this is Educare. There are a number of subjects that are on Educare. Yours is to go there, look for your subject, read. So you see senior 4 agriculture, senior 1 lower English secondary curriculum, senior 5 big production. So almost all the subjects are there. Yours is to go there, pick your subject, read through, and then you are able to progress in your academics. So someone is asking, are there geography S2 notes? Yes, create an account on Educare and access these materials. Then I also talked about mock papers, those who are candidates. We have set up different mock papers. So when you go and create an account on Yaka, your account should look like this when you log in. then go to My Courses and be able to access different mock papers. If you are in primary, P7 mock papers are there, social studies. Someone asked about geography. Here are geography papers. So if you open such a paper and you start on it, these examinations have been set like the normal exams that you do physically. Okay, instructions are there. So you go and start, for example, multiple choice questions. So here is the paper, you pick which one is your answer, you go to number 2, pick the answer, go to the next page, do your questions, and once you're done, you can submit them. The teachers will review them and they return the marks as well. Go to part B. For example, that was part A objectives, then you can go to section B, or okay, the other section, map reading. You also go through that map work. The same applies to the physics you are doing. All these mock papers have been put up for your own consumption. They are free of charge. Yours is to create an account. In case you need any guidance, please ask for it. You will be guided on how best you can access those mock papers. We also created a WhatsApp group to help you people ask and be guided. I'm sending the link in the chat section for those who may need to join the WhatsApp group, so that when you ask, someone can immediately pick your query and they help you. So Grace is asking, does it have a link? Which link do you need, Grace? Grace, which link do you need? Please, you can unmute and talk to me. The link that I've just sent in the chat section is for those who haven't joined the WhatsApp group. Join the WhatsApp group so that in that group you are able to interact, you are able to chat and communicate with different people. So someone is asking that, do those papers have links? Of course, once you have created an account, like this paper of geography, if I copy this link and I send it on our Zoom chat here, of course, it will ask you to first create an account. Can't access such a platform without having an account. Creating an account is also free of charge. So I don't expect someone to say that they are paying for creating an account. So the registration link, I said it is yaka.cc/register. So when you register, the link is there in the chat section. So access it and enjoy most of those mock papers. Yes, I see Shaban. Yes.
Teacher, can you help us with that?
I help you with what?
The link for Educare.
Yes, okay. I'm putting it in the chat section.
Okay, thank you.
educare.bz/register. If you want to see the courses that are before you can get an account, it is educare.bz/courses. I've sent the link of Educare as well. So with Educare, you will be able to see a number of courses. So this is Educare. Those who are seeing there, you can see we even have baby class reading materials, biology, top class, tenses of English. This is primary level. Those who would like to enjoy PowerPoint lessons, economics. So most of these lessons are there, senior 3 chemistry, senior 3 biology, lower secondary ICT, entrepreneurship, all these materials are there. Senior 6 geography 1. So in case you have your friends who would like to have a feel of Educare or Yaka Digital Network, share with them the links and enjoy what Yaka Digital Network has prepared for you. Teacher Daniel, are you in position to take it on?
I'm now back. I'm okay now.
Okay.
Okay, thank you
So
so
it's
much.
fine.
Okay. I've got some technical problem here.
Has it been sorted?
Yeah, I sorted now.
Okay, please.
Okay, fine. Thank you, my friends. I already have a friend like Eriki. I already have a friend like Peter. I have a friend like Martha. Have very many friends now here. Thank you so much, my friends, for waiting. Like Marilyn, Faith, you're also my friend Lorna, Arthur, Jonah, and Grace. Munyole, Shaban. Hope you're enjoying physics. Wycliffe Mutebi, Kennedy, Ojea, all these, and Raza. Not forgetting Raza. Okay, let me welcome you to this physics again. Let's move on from where we had stopped. Sorry for keeping around, waiting for me. That was good. Okay, hope you can see on my screen. You can say yes, then we move on.
Yes.
Okay, good, thank you. So we're answering part 2. An object of height 4 centimeters is placed 5 centimeters away from a pinhole camera. The screen is 7 centimeters from the pinhole. Draw a scale diagram to show the formation of an image by the pinhole camera. So this is a question that requires the use of a scale drawing. And I encourage learners always to use a graph book or a graph paper to do such a number. However, I will show you the way to go, and I'm very sure after here, you will share with me what you have got. I'm going to share the WhatsApp number. You send me the work, and then I think I'll look through and see how you've done it. We have an object which is placed in front of a pinhole camera. If I say this is my pinhole camera, this is the hole. I draw this line. So that when you get back and see the question, they're saying that the object is 4 centimeters high and 5 centimeters away from the pinhole. So if that is the case, then I'll say my object is 4 centimeters high and plus 5 centimeters. I'll measure from here to here to be 5 centimeters. I measure this distance, which is about 5 centimeters, using a ruler, of course. Then my object is 4 centimeters. So I make sure that 2 centimeters is up and 2 centimeters is down. I have 2 centimeters up here. This is 2 centimeters and 2 centimeters down here. I can as well put it down completely here, but just for simplicity, I do it that way. So the object is placed these centimeters away 5 centimeters away from the pinhole. Then I pick the ray from here, from the foot to the pinhole. And then from here to the pinhole still. So these are the 2 rays which I'll pick. Then they're saying that the screen is 7 centimeters from the pinhole. So I come with my ruler. I measure from here behind 7 centimeters. If my 7 centimeters is here, then where the 7 centimeters is where I'll draw my image. So this is my image. Now, the question is one, what are the natures of this image form? Of which at this time, I expect it to be as simple as taking porridge. I don't know how many of you take porridge at school, eat porridge at school, but you know how easy it is to eat porridge. Even without escort, you can eat it. Yes, Laureen, I told you I already have friends here, like Laureen, Maria Gret.
The image is inverted.
Very good, very good, very good. If you are in A level, I would say you go to campus and study engineering, right? It is inverted, it can be seen. You don't need a teacher to tell you that the image is inverted. It is clear, you can easily see that. I like the statement, you have not renamed yourself, but yeah, Mutebi Wycliffe. Real and inverted, very good Wycliffe. Real and inverted. So we have real. The next one is what I'm waiting for, Elijah.
The image is magnified.
Magnified, very good. It is magnified. At this point, you can tell that it's magnified. But if I just asked you, what are the properties of the images formed by a pinhole? You cannot tell me that it's magnified, not until when you know the position of the image and the position of the object. If you can look at this, the image distance is 7 and the object distance is what? 5. So 7 divided by 5, it is 1 point something. I think 1.4. So this is magnified. So that is that. I see very many, there's a way I like this class. I don't know, I think the organizer is going to help me so that you can have seminars every week. I can't miss seeing physics like this one for sure. Marilyn says it's magnified and blurry. I'm telling you, physics is flowing in blood here now. Good, thank you so much, Marilyn. There are still some hands up. Okay, they have taken their hands down now. Okay, good. So that is that. So you find that you have answered the question within a very short time and even without straining your head. Why? Because you understood what a pinhole is. When you know what a pinhole camera is, then the rest of anything about pinhole you cannot fail to what? You can't fail to answer it. Because everything becomes very simple for sure. Whether they ask which type of question, you cannot fail to answer it, as long as it's on a pinhole. Let us see this part. By the way, we have already answered almost everything. We have drawn the diagram. We have drawn the diagram. We have even gotten the nature. We have just got the magnification. I don't know how you people are saying physics. That is how physics is. As sweet as eating porridge at school, especially at 6. If your school does not give porridge at 6, just know that you don't enjoy porridge. It is always very sweet at 6. Very early in the morning, when it's late, when it's very early cold. Raza says physics is fun. That is very true, Raza. It's you. You know physics very well. It's just fun. I'm telling you, even we may even spend the night here speaking about physics. That is physics. Very simple and very interesting. Explain what happens to the image if the pinhole is made larger. Oh, Godfather, if the pinhole is made larger. When I make this one bigger, what will happen to the pinhole? Yes, somebody with their hands up. Elijah. Elijah is becoming my close friend.
The image will be more blood.
The image is going to be more blood. I like that. Let me hear from William. Yes, William?
The image becomes more bright.
The image becomes more bright. The other side says more blood. This side says more bright. Yes, who else is having another view? Where are my friends? Arthur, Jonah, Maria Great, Enrique, Johnson Kennedy, Liam, Lona, Mark, Saban, Wycliffe. Where are you? Okay, let me check on his chat. Maria Candy says the image is magnified and blurry. The image becomes brighter. That is Mutebi. Brighter, Mutebi Wycliffe. Then Larry says it's going to be diminished. Okay, yeah. When you make the pinhole big, oh God, it will be, please mark my words very well. If you make the pinhole big, it will no longer be pinhole because it's not big now. The hole will behave as if it has very many pinholes. Please, if you can get that statement, I'll be very happy and I say this part is done. If the hole is big, then it will behave as if it has very many holes. Is that okay? Before I continue, is that fine? It will behave as if it has very many what? Many holes. Is that okay? Say yes, no. Maria Candy says yes. Can somebody affirm that? Yes, Elijah. Good. Now, after each having very many holes, this hole will be produce its own image. This hole will 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 produce its own image. Now, we said this image's form will overlap. The image's form will overlap. After overlapping, it will form what we call to be uniform illumination. Please, I want you to mark my words very well for sure. It will form what we call to be uniform illumination, resulting into blurring of the image, or even the image becomes blurred. Oh God, if you increase If you increase the size of the pinhole, the very many pinholes, these images produced are going to overlap, leading to uniform illumination. And thus, there will be blurring of the image. Hello? If you are there, say yes. If you are there, say yes. Or people are saying it in the chat. Yes, yes, yes. Satongo says yes. Elijah says yes. Peter says yeah. Huh? Yeah, yes, yeah, 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 yeah. Jonah says yes. Victor says yes. Very good. So from today onwards, if somebody asks you what happens when the pinhole is made bigger? When the pinhole is made bigger, it will behave as if it is made up of many, many pinholes. So these many pinholes will produce, each will produce its own image. The images produced are going to overlap and then lead to uniform illumination. Uniform illumination leads to the blurring of the image. Robin says yes. Nasaza Alex says yes. Yo. Somebody says yo. I don't understand yo. Okay, good. Class, can we move to something else? Mutevi says yes, we move to something else. Please make sure you are getting something, you're going with something home that you'll never forget this seminar for. Good. Let's go to the differences distinguished between virtual image and real image. At this point, I expect somebody to know the definition of real images and virtual images. Can I have by show of hands somebody to give us? For sure, there's a way, I don't know. I think next week we should have a seminar of this type. I don't know what my boss is going to talk about, is saying about this. I can't miss seeing this class. Allow me pick Lauren. Yes, Lauren.
Virtual images are images formed by apparent intersection of light rays and cannot be received on the screen.
Oh, very, very good. I like the word cannot be found on the screen. While
real images is the image formed by actual intersection of light rays from an object and can be received on the screen.
Oh, Laurie, what is your best subject for sure?
Physics.
Mazima, I'm telling you, if you had not told me physics, I would know that you are lying for sure. Yes. How do you find physics, Laurie?
It's interesting.
Very, very interesting. Very sweet. Whatever word you put there, as long as it's a positive word, that is what describes physics. Yes, let's have a seminar next week. Elijah says, let us have another seminar next week. We shall look into that and see whether we can have another seminar for sure of this type. Virtual image is that type of image which is formed due to apparent intersection of light rays and cannot be found on the screen. Images formed due to apparent intersection of light rays and cannot be found on the screen. Oh God. What about the real images? There are those which are formed by actual intersection of light rays, and for them can be formed on the screen. Oh, Maria, great. I see you're also making me more happy here. Real images are formed by actual intersection of light rays from an object. Maria, great, you're very correct. Physics is fun. How will the letters of the word providence appear on the plane mirror? How will the letter of the word providence appear on the plane mirror? Before we do that, what are the properties of the images formed by plane mirrors? What are the properties of the images formed by the plane mirror? Kusima Peter, letter inverted, real, I want by show of hands. Can people raise up their hands? This friend of mine for sure. My friend, if you know you are my friend, unmute and talk.
The images are laterally inverted.
Very good. Elijah is my friend. The images are laterally inverted. Laterally inverted. Another property.
The images are virtual.
Images are virtual. I like that. Who is this one? Is it Lauren?
No.
Hey. What's that? Maria Candy. Good. Robin.
The image is erect.
Very good. I like the word erect. Erect is sometimes upright. Good. Let me go in the chat. Jonah says the image is laterally inverted. Daniela says the image is of the same size as the object. Very good. Image is of the same size as the object. Very good. This is too good. And is there anybody with another property? William says same size as the object. The image is the same distance. Very good, Mutebi Wycliffe. The object distance is equal to the image distance. Object distance equals to the image distance. Caleb says they have the same size. That is very true. Yeah. So these are the properties of the images formed by the plane mirror. And you need to know how, you see, me, I've told you, your work is to understand, not to cram in order to pass exams. No, your work is to understand what is taking place exactly. So let's see how the image is formed on the plane mirror. If I have my plane mirror here, this is my plane mirror. And I have this object. Then I tell you, can you draw a diagram showing the formation of this, complete this, showing how the image is going to be formed, the image of all. So what I will do, I'll just say, I complete this line. I can complete this line. I can draw that one as well. I pick a ray from here, which will strike this one at an angle of 90 degrees. The ray striking at 90 degrees will be reflected along the same path. So this ray appears to be coming from the other side. Now, I pick another ray, which is going to come from this now. Let me complete this down. So I'm going to pick two rays. One is going to come from here, striking this one at this point. I can make it strike at that point. Then I draw this normal. Then it appears to be coming from the other side. I mean, it's going to be reflected. And it appears to be coming from this side. Let me use the point object. This one is not bringing it clearly. This is my mirror. This is my plane mirror. I have an object placed here. So if this is my object, I'm using a plane object, a ray of light. I have to pick two rays. One will come from here. It will strike it at this point and then it will be reflected along the same path. So it appears to be coming from somewhere there. Then I pick another ray. It will strike it at this point. When you strike it at this point, I draw a normal here so that this becomes the angle of incidence. The angle of incidence is the same as the angle of reflection. So this ray is going to be reflected back like that. So it's reflected back, it will appear to be coming from somewhere. Where these two rays are going to meet, these two rays are going to meet, but they're going to meet at this what? At this point. This is our eye. Now, when you look at these two rays which are meeting, they are not real images. They are not real rays, but they are apparent what? Apparent rays. So being apparent rays, that's why the image form is going to be what? Is going to be virtual. So somebody says, pardon, sir. When you tell me pardon, I cannot hesitate. Because I want by the time somebody leaves my class, that person leaves when he has things not only in the book, but also in the head. We are talking about our plane mirror. This is our plane mirror. I'm placing an object in front of it. So if I place an object in front of this plane mirror, I want to know how the image is going to be formed. So I pick two rays. The first ray is here. It will go and strike it at an angle of 90 degrees. When it strikes at an angle of 90 degrees, it will be reflected along the same path. So this ray, the reflected ray, appears to be coming from behind here. The one coming from behind, we use the broken line. Then I pick another ray, which is going to strike this mirror at another point here. When it strikes there, I draw a normal here so that this one becomes the angle of incidence. So this ray which has been incidence at this point is going to be reflected, but the angle of reflection should be the same as the angle of what? Angle of incidence. So this angle should be equal to this angle. And this ray, which has been reflected, appears to be coming from this side, and it will meet the other one. Where the two meet, that is the position of the what? Of the image. Hope that is clear. The one who said that, pardon, Mwesiga Victor. Is that clear? Yes, Mwesiga? Okay, good. Let's move on. So they're saying the word providence. How will the word providence appear on the screen? I mean, on the plane mirror. Providence. So if you place providence in front of the plane mirror, if you place providence in front of the plane mirror, this one will come first, this one will come second, this one will come third, this one will come fourth, fifth, and this one will be the last letter. But all of them will appear when they are laterally inverted. When you say laterally inverted, this is the meaning of laterally inverted. If I'm here, and this is my left, and this is my my right. I mean, let's say this is my right, this is the left. So if I'm to appear laterally inverted, then my right comes to the left, and my left comes to the comes to the right. That is what we call to be laterally inverted. William is asking, teacher, is that what you're supposed to do if the question asks? If the question asks you to sketch the image formed by the plane mirror? Yes, exactly. What you are just seeing is what you're supposed to do, William. If they asked you to draw the diagram showing how the image is formed on the plane mirror, you just get your image. You just get your image, you place it in front of the mirror, pick a ray, strike it there, it appears to be coming from the other side. Pick another ray, reflect it, it appears to be coming from there. This is the image. Let's go to the providence. This E is going to change. This part will come first, so it will change and it will be like this. Can somebody say yes, if that is the case? Actually, somebody was supposed to draw for us, only that we don't have a pen to draw. Mutevi confirms that it is correct. Can somebody also say yes? Good. Setongo says yes.
Yes.
My friend Saza is raising up the hand. Yes, Saza?
Yes.
Okay, good. So that is letter E. Then S, this S, we shall start with this, which will come here. S will come like that, S will come like that, and this will be S. Can somebody say yes? Okay, people are saying yeah. Lois says yeah. Voice, I mean, Liam voice says yeah. Good. Then let's go to N. N, this part is going to come first. This part will come first. It is there, then it will go there, then this. So it will be like that, and then that. Can somebody also say yes? Can I? Yes, Mutevi has confirmed. Good, Maria Candy has confirmed. Good, let's go. Then E is the same thing. We had already drawn E. Then D, this part will come first. This one will come first and this one will be behind. So we shall have this part coming first and this part will be behind. Then I will not change. I will not change. It will remain as I. Even V will not change. V also won't change. O also won't change. also won't change. Then Ara, this part will come first. So we shall have something like that. Can somebody say yes for Ara? Good. Then lastly is P. This part will come first. So we shall have P here. So eventually, this is how Providence is going to appear on the mirror. Is that okay? I don't know who can share for us the screen. I want us to write great. How will great appear? Maria great. Maria great, do you have H in your name? Is Maria great still there? Maria great, do you have H in your name?
Yes, teacher.
Okay. I see Caleb is trying to write for us on the screen. Caleb, you write for us. Very well. Oh, we are mixing issues. Let's write one by one, eh? Let us see from Caleb and then Setongo. Setongo, you can remove yours. Oh, good, Setongo. I like the discipline we have for sure. Are you able to see what Caleb has written, class?
Yes, sir.
Is it the right one? Is that the way the great will appear? Can somebody confirm that? Maria Grace says yes. Liam Boy says yes. Yes, everybody says yes. Okay, good. So that's how it's going to appear. Thank you so much. I'm so delighted and happy for sure. You people are learning and you have physics for sure, Mazima. I have seen we have a lot of physics in our heads. Let's always read physics to understand it. And with that, we can always win physics. We can get marks. Somebody says another example. If that number came, I would crush it. Elijah says, if that number came, I would crush it. Oh, you would just, for me, I say that I normally tell people that you can swallow physics even without chewing. The last example, possibly, let us use the word. Which word should we use now? Which word should we use? Can somebody suggest a word? Hello? Somebody has suggested in the chat. I wanted somebody to just suggest a word so that we can use as another example to see how the word is going to appear. Newton's law. Somebody says Newton's law. Newton's law. Okay, somebody was saying, teacher, how do I use the pencil? Oh, Maria Gloria, there's the heading here, it is what we call to be, there's somewhere we call to be annotate. If you say annotate, Then you pick a pen. Yeah, you pick a pen. That is how people are able to write. This is annotate. Say annotate. Yeah. So good. Newton's law. Newton's law. Let's see. It's going to how it's going to come. W will come. Will not change. A is not going to change. L. This part will come first. Then the other part will come last. Then S. This part will come first. Then it will be something like that. Apostrophe will not change. N. This part will come first. That is N. O will not change. T won't change. W won't change. E will be like that. And then N will be like that. Newton's law. Can somebody confirm that? That is correct? Is that correct? Oh, yeah. People are saying, yeah. Good. That is that when it comes to the formation of these images on the plane mirror. Please allow me go to this derivation. A mirror is in position M1 and is incident on a ray of light, with a ray of light at an angle theta. The mirror is then rotated through an angle theta 2 to position M2 while keeping the direction of the incident ray constant. Show that the reflected ray is rotated through an angle 2 theta. Please, I want us to be attentive here. I want us to be attentive here for sure, because this derivation is very interesting, but also has its own challenges. So the mirror is, they're saying that the mirror is incident. The mirror is incident with a ray of light. This is our mirror. It is incident with a ray of light. Before we go to the question, please listen very well. Listen very well. Lorna says that if I have a comma, do I change the direction? Yes, you have to change the direction of everything. Now, if we have this ray which is incident onto this mirror, if it never met the mirror, it would have continued. Can somebody say, yes, it would continue if it never met the mirror? Do you think it would continue? Good, Mutebi. But because it met the mirror, it is reflected. Because it met the mirror, it is reflected. Now, the ray has changed the direction. Initially, it was going here, but finally, it is there. This is what we call to be the incident ray, and this is what we call to be the reflected ray. This angle is called to be the angle of incident. And this angle is called to be, who can give me the name of this angle? This one which I've just put here. What name is given to that angle? What name is given to that angle? Yes, Elijah?
Glassing angle.
Very good, very good. It's called to be the glassing angle. Kusima Peter says angle of incidence is the glancing angle. Very good. So this angle is called to be the glancing angle G. Then I want you to see this angle, that angle. What name is given to that angle? What name is given to that angle? Raise up the hand or you use the chart. What name is given to that angle, the one which I've just shown? William, yes, William. Yes, William.
Yes, teacher. It's called the angle of deviation.
Unmute. Okay, Elijah.
It is, I think it is called deviation.
Angle of deviation. Let me hear from my friend Riza. Yes, Riza. Raza. Okay. Refracted ray angle of deviation. Very good, Mutebi Weekly. So this angle is called to be the angle of deviation. By definition, angle of deviation. I'm going to write it here so that those who can copy it. Angle of deviation is the angle between the original direction of the light ray and the reflected ray. That is the angle of deviation. Is the angle between the original direction of the right ray and the reflected ray. So that's why you're saying that if this ray never met this surface, never met the mirror M1, it would continue in a straight line. But because it met it, it was reflected along this. So this becomes the reflected ray, and William says, teacher, may you please repeat the whole concept? I cannot state why ambulance is written laterally inverted on ambulance van. Okay, teacher, is the deviation ray that broken? Continuation of I. Okay, let me repeat that part. I said that if the ray is incident onto the mirror along this path, and it never met the mirror, if this mirror was not there, then it would continue in a straight line. So this is the original direction. Originality, direction. The direction it was supposed to take if it never met the mirror. But because it met the mirror, it is now reflected. So this is called to be the reflected what? The reflected ray. I think you get the difference between the reflected ray. So the angle between the original direction and the reflected ray is what we call to be the angle of deviation. I don't know whether I'm clear now to everyone. Elijah, am I clear? Okay, Elijah says, I am very clear now. Thank you so much. He says, yes. He says, yes. He says, yes. He says yes. Okay. So we are saying that angle of deviation is the angle between the original direction of the light ray and the reflected ray. Then what about the glancing angle? I want us also to get the glancing angle. Glancing angle, I think from here somebody can see the meaning of glancing angle. From here, what is the glancing angle? Who can define for us glancing angle now? You can raise, from the diagram, you can define it. You can raise up the hand and you define for us glancing angle. From that diagram which I've just drawn.
Yes.
Yes?
Hello.
Yes, Lorna.
I think it is the angle between the incident ray and the surface of the mirror.
Angle between the incident ray and the.
Very good, very good. The angle between is the angle between the incident ray and the mirror. The angle between the incident ray and the mirror is what we call to be the glancing what? The glancing angle. Okay, angle between the incident ray, that is William, and the glancing angle. Good. Now, I want you to note that this angle is also the glancing angle. I think this angle. Please, can somebody say yes? From here to here is the glancing angle. Can somebody say yes? Very good.
Yes.
Good.
Alternating angle.
Very good.
Yes.
It is opposite, not alternating. It's opposite. This angle is also the glancing angle. Can somebody say yes?
Yes.
Very good. So that means that the angle of deviation is the glancing angle plus the glancing angle. Can somebody also say yes there? Is that true?
Yes.
Oh,
Yes,
good,
it's
good.
true.
Very
Yes.
good.
Yes.
So that means that the angle of deviation is 2G. Is that correct anyway? Is that correct?
Yes. Yes, teacher.
Very good. Okay. Great. Great. Now, check what I'm going to do. Please check what I'm going to do. This is my normal. I'm going to rotate the mirror, okay? I'm going to rotate the mirror. Have you seen I've rotated the mirror? Have you seen I've rotated the mirror?
We are seeing.
Now my question is, where is Ara going? After rotating the mirror up to this position M2, where will Ara go? Please unmute and tell us, where will Ara go?
Teacher, at the normal.
Very good, very good, very good, Elijah. Not at the normal, but towards the normal, not so?
Yes.
Please, can the rest also tell me yes?
Yes.
Yes.
Very good.
Yes.
So the
Yes.
reflected ray is going to go towards the normal. This is the reflected ray. Yes. So my reflected ray will go towards the normal. So this becomes Arawati, Ara2. So if I've rotated the mirror through an angle theta, can somebody kindly tell me my new glancing angle? What is my new glancing angle? Bear in mind the definition of the glancing angle. Remember, this is my mirror now. This is my new mirror. What is my new glancing angle? Please raise the hand up. My new glancing angle. What do you mean my new glancing angle?
Is it G plus theta?
Very good. Who is this one? Patrick. Patrick Sebanenja. Are you Patrick? Patrick, are you the one?
Yes.
You are now my friend,
Yes,
okay?
sir.
You are my friend now, okay?
Thank you.
So Patrick says the glancing angle, the new glancing angle is the angle between the incident ray and the what? And the mirror, which is the whole of this one. Is that okay, friends? Which is going to be G plus theta. Is that okay, friends? Please, if it's okay, say yes. Or if it's not fine, say no.
It's okay.
It's okay. Very good. I like Nasasira Ethan. Ethan says G plus theta. Very good, Ethan. Very, very good. Okay, so this is my new glancing angle. Now, I want us to see the deviation. The deviation is going to be, let me call this one to be D1, the first deviation. It was D1. Now, the second deviation, the new deviation. New deviation. New angle of deviation. That one you can call it to be D what? D2. It's from here. Remember we said the angle of deviation is the angle between the original direction of the light and the reflected ray, okay? So it's going to be from here to here to here. Where's the reflected ray? The reflected ray is that one. Is that okay? Please let me know whether that is fine.
Teacher, I beg your pardon a little.
We are saying the new deviation now, the new angle of deviation. It is from the original direction of the light ray to the reflected ray. Remember, we now have the new reflected ray, which is this one, not so? This is our new reflected ray. So the original direction is here. So I have to move from here up to the new reflected what? Up to the new reflected ray. Is that okay?
Yes, teacher.
So that becomes D what? D2, not so?
Yes.
Okay. So D2 is going to be 2 times the new glancing angle. So it's going to be twice the new glancing angle, which is what? G plus what? Plus theta. Is that fine?
Yes.
Okay. When you open the brackets, what do you get? It is 2G plus 2 what? Plus 2 theta. Okay, good. Now, we want the angle between the 2 reflected rays. Alpha. Teacher, my connection was off. What do theta represent? Theta is an angle just. Now, I want somebody with two eyes working very well to tell me the relationship between alpha, D2, and D1. Somebody who can see the relationship between alpha, D2, and D1.
Alpha is D2 minus D1.
Who is this one for sure? Your eyes are working very well. Wait, is this Patrick?
Yes.
Who is this one? Patrick?
Yes.
Patrick, you must be dangerous.
Not as such.
I want some other person also to see it and speak the same thing. Who else has seen it? Who else has seen it? The relationship between D1, alpha, and D2. Ethan, you are not talking, but I like the way you are doing things. Ethan, if you could unmute yourself and talk. Alpha is D2 minus D1. Very good, Ethan. Ethan, can you unmute and speak that answer? I cannot just read that without hearing it from you. Ethan, unmute. Okay, your network is not very clear, but it's fine. Okay, so now that two people have confirmed, so we say that from this diagram, alpha is the same as D2 minus D1. So we substitute. Our alpha is going to be D2 is here, which is 2G plus 2 theta minus D1 is here, which is 2G. So the 2G and 2G will go. I remember alpha to be equal to 2 theta. This is the expression that they wanted us to derive. They wanted us to show that the reflected ray will rotate through an angle 2 theta when the mirror is rotated through an angle theta. This is the expression. Okay. I like the physics in your head, you people. Your physics is too much. Maria Grete, I think Maria Grete joined a little bit late. She had phone when I'd already drawn the diagrams. I think I will do the repetition maybe in a later time, but it's fine. Let's take the screenshot. For those who want to take the screenshot, you take the screenshot of that. Good. Let's move on and we complete this question. So they're saying that Anne intends to obtain 5 times images of herself using, Anne intends to obtain 5 images of herself using 2 plane mirrors. At what angle should she incline the mirror so as to achieve her intention? So she wants to obtain 5 images of herself using plane mirrors, but she has only 2 plane mirrors, but she wants 5 what images. So what angle should she incline the mirrors so that she can what? So that she can see the whole of herself. I see hands up here. Yes, Lauren.
60 degrees.
60 degrees. Okay, let the calculation tell us. Lauren, how did you arrive at the answer? Can you tell us?
The number of images equals to 360 minus 1 divided by theta.
360 divided by theta minus 1, right?
Yes.
But she wants to obtain how many images?
5.
5. Very good. Equals to 360 degrees divided by theta minus 1. So we take this one this side. It is a negative. When it crosses the other side, becomes a positive. So we shall have 6 to be equal to 360 degrees divided by theta. Then from here we cross multiply, right?
Yes.
So this by this is 6. Theta should be equal to 360 degrees. Divided by 6, divided by 6. So theta would be 60 degrees. Very good, Lauren, for simplifying work for us. Very good. Very good. Go to campus, Lauren, and study engineering. Or you want to be a doctor, Larry?
I don't know.
Okay. I'm going to pray for you so that God can reveal to you your dream course and you work towards it. Okay. Let's move to the next, unless there's somebody with a question. Do you have anyone with do you have anybody with a question on this? In case everything is right, let's move on. If it's not fine, you can say pardon. Is everything correct here? I mean, okay here? You can use the chat. Says yes, teacher. Okay. Great. Good. Okay, lastly, as you wind up on this, draw a ray to show the formation of images on the concave mirror when the object is at F, at C, and between F and C. We're going to be a little bit faster on this. Time is going at a very high speed. I told you, with the physics, you can speak the whole physics, where you find the time is running very fast. That's how speed physics is. Even birds, they enjoy physics. You never know when the bird is singing on the tree, singing because of physics. Okay. Object at F. We are talking about here, we are talking about concave mirror with the object at F. Where will the image be formed? When the object is at F, where will the image be formed? Okay, yes. Peter says that, can I put back the calculation? It's okay, let me put it back. I think he wants to take the screenshot. You can take the screenshot. You can take the screenshot. Okay, Lauren, you are telling us where the image is going to be formed. When the object is at F.
The image is formed at infinity.
Very good, very good, very good. When the image is at F, when the object is at F, the image is formed at infinity. So if this is our concave mirror, You make sure you measure from here to be the focal point. Then you also measure the distance from the focal point to the center of curvature. Make sure they are the same. The distance from here to here is the same as the distance from here to here. Then we shall have our our object at F. The ray of light will go and strike the mirror. A ray of light that strikes the mirror, a ray which is parallel to the principal axis, converge to the principal focus. So it will converge to the principal focus, and it will continue. Then we shall have a ray through the center of curvature. The ray through the center of curvature will pass through undeviated, or it is reflected along the same path. So it will have that. So you finally see that these two rays are parallel, and if they are parallel, the final image will be formed at infinity. So this is the image formed. Maria Gloria says, teacher, sorry to take you back, but where does the calculations come from? Okay, Elijah is saying that it is standard. I think it's standard. It's a proven formula. Yeah, Maria Gloria, we don't prove that formula here, but we use it. Experiment has shown it that if you have two plane mirrors inclined at a certain angle, then you'll have number of images formed. But the number of images formed depends on the angle at which the plane mirrors are inclined. So the relationship is given by that formula. Theta, number of images equals to 360 degrees divided by theta minus 1. Okay. So we are talking about object at F. When we have object at F, then the ray of light from the object, that method teacher pattern with FC thing, okay? So we are talking about the plane mirror, the images formed by plane mirror, by a concave mirror. We have our concave mirror there. We said if you want to construct it clearly, you measure the distance from here to here to be the focal point, and the distance from the focal point to the center of curvature, they're supposed to be the same. So this is the center of curvature, this is the focal point. We are saying our object is at F. If the object is at F, Laurin told us that the final image is infinity. So we shall have ray of light from here to here, striking that. This one will come and pass through the principal focus. A ray parallel to the principal axis is reflected through the principal focus. Then we have a ray through the center of curvature. It will strike it at that point, and then it will be reflected along the same path. So this ray will appear to be coming from the other side. This will also appear to be coming from the other side. So this is the same ray which are drawn here. It's the same right here. Principles are there which we follow in order to obtain that. Okay, at C, when the object is at C, the image is also formed at C. When the object is at F, the image, when the object is at C, the image is also formed at C. When you follow the principles, it will automatically give us that. Now, I want us to talk about this. Properties of images as we conclude on this. Properties of images formed by concave mirror. Properties of images formed by concave mirror will vary depending on the position of the final image. So, I mean, of the object. So, if the object is at F, object at F. First of all, the image is at infinity. Two, the image is magnified. This one is done using construction. I'm going to prepare, we're going to organize a seminar again. We're going to see some of these things. How to construct the ray diagrams, because we need to know it from first principles so that we can avoid the groundwork and what. So I'm going to do that and we have it done. So don't worry about that. I have to cater for all the individual differences here. Then I'm interested in the for object at infinity, for object at infinity. When the object is at infinity, infinity means distant object. Distant what? Object. So if we have our concave mirror, and you have your object at infinity. If you have your object mirror, I mean your object at infinity, this is our focal point, and you want to know how the image is going to be formed. You pick a ray of light from the object. One of them must pass through the focal point. Then it's reflected parallel to the principal axis. And then another ray is supposed to hit at the focal point, I mean at the pole here. This angle becomes the angle of incidence. Then supposed to be reflected, but the angle of incidence should be the same as the angle of reflection. Angle of incidence is supposed to be equal to the angle of, yes, William? Your hand is up, William?
Yes, teacher. I had a question, but it's okay. I've got the answer.
It's fine, eh?
Yes.
Okay, good. So this one has to come. And hit it here. So where these two are going to meet, the angle of incidence should be the same as the angle of reflection. Let me remove this. So I said, this is the focal point F. You pick a ray of light and reflect a parallel. Then you pick another one, hit the mirror, and then reflected here. So it's supposed to actually meet, only that I'm not using a ruler. It's supposed to meet at this point. So if the image is at infinity, then, I mean, if the object two, the image is inverted. 3, the image is diminished. Then lastly, the image is real. These are the 4 properties of concave mirror when the object is at infinity. Then lastly, which I want to talk about as we wind up this, is when the object is at the center of curvature. When the object is at the center of curvature, I said this distance is the focal point F, this is the center of curvature C. So if I put my object at the center of curvature, this ray will come there, it will strike, then it will be bounced back here. Then this one will come here, it will strike it at that point, then it will bounce back here. So the final image is from there. So the object and the image are at the same point. This is going to drive us to the next step. The final object, the object and the image are at the same point. So we say that the object and the image coincides. We use the word coinciding. When the object is here and the image is here, we say that the object and the image are coinciding. This is how the image is formed on a concave mirror when the object is at C. I'm so sorry, we are not digging deep into the principles, but then I think when you organize the next seminar, I'll make sure that they dig deep into it so that at least we get the real clue of everything. Let me see the questions we are left with. If time can allow, we can do it. If not, we may not do it. I think we have, with the aid of a diagram, describe an experiment to determine the focal length of a concave mirror using an object pin and no parallax method. That one is too simple that we can do it now. If I want to determine the focal length of the mirror using the no parallax method, what I do, please listen to me very well, because it's what is going to help us in the other calculation. I get the concave mirror whose focal length is required. I get the concave mirror whose focal length is required. I place it on top of a table with its reflecting surface facing up. I get the concave mirror whose focal length is required. I place it on a table with its reflecting surface facing up. Then I get the object pin O. Then I hold this object pin above the mirror with its tip on the principal axis of the mirror. Are you following me? Are you following me?
Yes.
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 Yes. Okay. So I get the object pin. Maria Gloria is trying. I think, don't worry, my friend. Everything's going to be okay. So I get the object pin. I place it so that its tip is on the principal axis of the mirror. Then I'll move this pin up and down I'll move it. So I move it up and down. If I move it, the image will come here. The image will come here until when the image is at this point, coinciding with the object. Do you hear me? When the object and the image appear to be at the same point, you stop. Then you measure this distance. You measure this distance. You call it to be R. Because this distance is the radius of curvature. Calculate the focal length from F equals to R divided by 2. The focal length is just the radius divided by 2. The radius of curvature, the focal length is then calculated from radius of curvature divided by 2. Please, what I want you to note here is that the point of coincidence is the center of curvature. That is where the image and the object are at the same point. And so that becomes the center of curvature. And at that point, the distance of curvature. Good. Now, there you'll have calculated the focal length. Now, the time is just on our neck, but let's do this last calculation. Then we shall continue from there. And we shall do it from here. In an experiment using an object pin and not vertically above the mirror, which the object pin coincides above the mirror. Which distance is that? Those who have been following, which distance is that? Yes, please, which distance is that? Hello?
15 centimeters.
Which distance is that 15 centimeters? Sorry? So that is
image height.
This becomes now the radius of what? The radius of curvature. So our radius of curvature. Then the question is, what is the focal length? Yes, Kusima Peter says radius of curvature. Very good. Then he says, what is the focal length? Focal length equals to radius of curvature divided by 2, which is the same as 15 divided by 2. What is 15 divided by 2? What is 15 divided by 2? Isn't it 17.5? I mean 7.5. It is 7.5 centimeters. Okay, that was so good. Maria Candy, I want to thank each and every person who managed to make it a point to be up to here, up to now. Allow me to call upon Bernard to take us through as we close this session. Mr. Bernard? Yes, Mr. Bernard? Yes, Mr. Bernard?
Yes.
You can now take us through and you close the session.
Okay.
Okay, let me stop sharing.
Yes, thank Thank you, Teacher Daniel, for leading us in today's seminar. And I'm sure most of us have understood. If not, come again in the next seminar. Tomorrow we have more upcoming seminars. In the morning at 11 a.m., there is the one of primary. It is English. In the afternoon at 2, there is that of advanced level, which is sub-mathematics. You can tell your colleagues to join in at the right time. So I've shared with you links to create accounts on Yaka, links to create accounts on Educare, and also joining our WhatsApp group for the seminars, so that in case you have any challenge in either creating an account or accessing content, you can put in the chat section so that you are guided. Are there questions that I can respond to? We can have some few minutes to interact.
Teacher, is it confirmed the next Saturday we have a seminar?
Come again?
The teacher of physics has been promising a seminar. Is it confirmed?
Teacher Daniel, which date have you promised us? Teacher Daniel? I think he has gone to take a bottle of water. Let's wait for him.
Okay.
But we shall keep communicating in our group. Yours is to keep following the discussion. And now that everyone can type in that group, we don't expect it to be crowded. Very many messages. At least let's leave the key messages for people to see and interpret them. So Shaban, have you managed to create an account?
Up to now, I'm still fidgeting with just.
On Yaka or Educare?
Educare.
Because I see on Educare you already have an account, so yours is to simply log in because your account is okay. So you are going to log in with your email. Yes, that is the email as your username. Then the password, you can set it again, or I'm going to send you your password in the chat section. Okay? Yes, you already have an account.
It's telling me the username, not the other side. I think I forgot the name I used the other side. But since you have already.
So I've sent your password. You can change it anytime you want. I've sent your password. Use the email and that password to log in. Any person who has a query? Yes, let's continue and create accounts on Yaka, access those different papers, those mock examinations that we have set, benefit from them, then create accounts on Educare to read your different subjects. All those are free of charge.
Maybe Mr. Bernard, I don't know.
Yes.
Whether you've told them, because I want to bring it to our learners that we are a school. We operate as a school. So anything you want and is related to academics, we are there to handle you. So you just need to give us a call. And we have our learners, we teach them every day, the physics, all the subjects. So during this holiday, for those who are in a holiday, if you wish to have like holiday coaching, we can absorb you into our system. We can absorb you for 1 month. Every holiday you come and you study with us. There's no problem with that. The terms and conditions, maybe Mr. Bennett can talk about it. The terms and conditions. But we're a school, we welcome people from different parts of the country, and we make sure we give you the best online study. Our students have always appreciated our work, and I'm sure if you can be part as well, you can also appreciate it. Thank you. Maybe Mr. Bernard, I don't know whether you had already told them about that. Yes.
Okay, now that some of you are in holidays, if you would like to join Onyaka maybe for a month, we normally charge 100,000. Then for those who are interested to keep learning more than a month and you'd like to pay for a year, we charge 500,000. So in case you need to get enrolled, feel free also to chat with us in that WhatsApp group. You can also inbox us and we give you more guidance. So join that WhatsApp group, and then for any other queries can be put from that group. Okay.